Earlier this year, astronomers discovered one of the closest supernovas in decades. Now, new data from NASA's Chandra X-ray Observatory has provided information on the environment of the star before it exploded and insight into the possible cause of the explosion. On January 21, 2014, astronomers witnessed a supernova just days after it went off in the Messier 82 or M82 galaxy. Telescopes across the globe and in space turned their attention to study this newly exploded star. Astronomers quickly determined this supernova, dubbed SN 2014J, belongs to a class of explosions called Type 1a supernovas. These supernovas are used as cosmic distance markers and played a key role in the discovery of the universe's accelerated expansion, which has been attributed to the effects of dark energy. While astronomers agree that Type 1a supernovas occur when a white dwarf star explodes, they are not sure exactly how this happens. For example, do these supernovas go off when the white dwarf pulls too much material from a companion star like the Sun, or when two white dwarf stars merge? Researchers used Chandra to look for clues. They took observations with Chandra about 3 weeks after 2014J and compared it with Chandra data taken prior to the explosion. They found, well, nothing. Although it may sound counterintuitive, this non-detection of X-rays actually told astronomers quite a bit. Specifically, it showed that the environment around the star was relatively free of material before it exploded. This means that it's very unlikely that a messy transfer of material between the white dwarf and a companion star took place. Rather, whatever caused SN 2014J to explode cleared out the space around the star beforehand. This helps astronomers narrow down the possibilities and get closer to the answer of just what caused SN 2014J.